Okay, so this is, oh, we are going to be done this week. How many sections are there?
Is this just quarter 3, right?
Hold on.
What's this right here?
6, 2,
I thought quarter 1.
6, 16. We've got 2 more sections after this. So, thank you. So we've got this, 2 more sections, we're done. Then we test. Yeah. What? This is 6-5, we got 6-6 and 6-7. We already did 6-8, we bumped it to the front, remember? So, in 6-5, sorry. What we're doing is we're going to be solving equations that have radicals in them. So square roots and other type roots, type of problems in there. Let's just jump into it. You guys know how to solve equations, right? Usually when you're solving the equation, you're trying to undo what was done to the problem. So if you guys remember the order of operations, right? That's the order of operations. Usually when I'm solving an equation, I like to use it as much as I can in reverse. Okay, you want to undo that in that order. No? Oh, you're trying to nudge them. So anyways, let's get started solving square root equations. As always, please watch me do the first one, copy all the notes, and then you guys can try the next one. So I've got this problem here. I want to get x. But before I can get x, I want to get that radical by itself. Kind of like with the absolute value. You guys remember that? We want to get the absolute value by itself. In this case, they're adding 3 to that. So the first thing I'm going to do is subtract 3 to both sides. Which property did I just use? Subtraction property of equality. So I've got square root 2x minus 3. That's going to be equal to 5. I want to get rid of that radical there. That is a square root, isn't it? So if I want to get rid of a square root, I have to square it. Square it. So I'm going to square this side. And of course, golden rule says what you do to one side, you got to do to the other. So I've square root the entire left side. I'm going to square root the entire right side. So what happens here? Square root are gone. I've got 2x minus 3 is equal to 25. And now I've got a simple 2-step equation. Okay? I'm going to add 3 using addition property of equality. I've got 2x is equal to 28. Division property of equality. X is equal to 14. Now, don't call it done at this point. What should you do with your equation? Plug it in. Why? To see if it works. Half of the people that get this wrong is because you didn't check your work. Because this is something that even makes sense, but because you got to x, you thought it was good, you turned it in, and you lost points. Plug it back in, see if it even makes sense. What should I not get inside of this radical? I should not get x. No, I shouldn't get a negative number in there. So if I've got this huge negative number, that's going to make this even bigger, make it a full negative, which means, no, I'm sorry, that's not correct. I shouldn't have an imaginary number in there. Make sense? So there's the problem. Go ahead and copy that down. Any questions on any part of it? Thank you, Shanla. Mr. Shanla. You need to write this down, please? Dan, put that away, please.
It worked.
Good. Thank you. Hip, hip, hooray. You look so comfortable. So you look so comfortable.
Thank you.
On what? Hey. Oh, I thought you were going to take the shot.
Makes me something like that.
Can I change the slide now? We're good? All right, go ahead and try this now yourselves. Give you guys a few. Call somebody when we're done. Yep. Filter. Maybe I just want to wait for it to go. You want mine for you? Oh man, that's been a long time. Did you? I kind of can't miss it because I'm in school, so everyone's doing it. Did we do the damn chicken noodles?
No.
Oh, that's hilarious.
Mr. Munoz.
Yep. Can I go there?
Yeah, I did. Can it ever be like untrue or something? I don't think
Well, let's see what happens. We can try to get it. All right, thank you. Thank you. Sounds like you guys all got it. Let's see what how you guys did. So we've got 4x plus 1 is equal to 5. Square rooting both sides. 4x plus 1 is 25. Take 1. 4x is equal to 24. So x is 6.
well,
Right? Wait, did I do that wrong? Okay. Check it. Let's check it. So square root of 4 times 6 plus 1 minus 5 should give us 0, right? So 24 plus 1 minus 5, so the square root of 25. That is 5. 5 minus 5 is definitely 0. So there we go. Questions? You see those fifths, fives, fifths of 5. 5 means I can teach somebody. 4 means I'm good. 4 means I'm good. 5 means I can teach somebody. 9. Word. Okay. Alright.
This is the first thing I've got.
No, you do get everything, but it seems like over the unit it starts to go less. Like at the beginning, it's like, I'm strong, I got this. And it's like,
It just adds more shit.
more math. Yes, sir.
You really just put the word other in there?
Well, let me tell you why. Because if you think about what we did in the last section, solving radical equations doesn't necessarily mean there has to be a radical symbol in it, does it? So when you look at this, you don't think, oh, that's a radical equation, right? You don't think that. So these are radicals, except they're expressed as rational exponents. So yes, I really did put the other in there. Okay? So let's take a look here. I know that 2/3 is going to be some kind of weird radical, right? So I want to make sure that I get it by itself. First thing I'm going to do is divide by 3. Yeah, get it by itself. So we're going to get this going on. So I've got x plus 1. Now this is to the second power, and it is the third root of that. So that's going to give me, is that 4 on the right side?
Oh yeah.
Oh, haha, JK, thank you. That should be a 1. All right, so we're good now? We're good now? See, some people write, so I'm going to wait for you. Sir.
Actually, let me put the check.
Why would I do what?
That square root of 3.
Because remember, it's the power over root, so power and index. So the index is 3. Now, did anybody think of putting that 2 on the outside? No? Okay. There's a couple things we can do. Here, I'll do them side by side. Because I know some people are like, I thought of that. So some people thought this is the third root of x plus 1 squared is equal to 4. Do you see the difference? And the difference is where we put that power. Okay?
Oh, that's good.
Now, I actually like the one on the right better. Because it's squared. How do I get rid of a square?
Square root.
Square root, right? Square root both sides. That leaves me with the third root of x plus 1 is equal to 2. How do I get rid of that cube root? By cubing it, right? So now I cube this. Cube that. These are gone. X plus 1 is equal to 8. When I subtract 1 to both sides, x is going to be 7. Let's see if we can get to that on the other side. So here I've got this. I'm going to go ahead and cube both of those. That makes this gone. So I've got x plus 1 squared is equal to 64. Square root both sides. X plus 1 is equal to 8, is it? Subtract 1. X is equal to 7. One more time.
Do you have to put the parentheses on the one on the right? Or can you just kind of, because at first I didn't see that, I just kind of left it to.
It's up to you, but personally I like to keep it to make sure I know stuff stays together. Okay? Sorry. Sorry. Where? Let's go to here. Let's go again. Is this where you went? Are you okay with the cubes? Or should I start that again too? Yep. Okay, sounds good. Let me get rid of the whole problem. Let's just get rid of it all. Okay, so I want to get rid of this index of 3. And I'm going to do that by cubing both sides. This will make that go away. And you'll end up with what's inside, which is x plus 1, quantity squared. And that was, what did you say, 64? Okay. Now, I want to get rid of this square. I can use my square root. So, I square root and I square root. That leaves me with the inside piece, which x plus 1 is equal to 8. And if I subtract 1, I'm going to get x is 7. It's whichever one you see. Like I said, half of you guys saw one way, the other half saw it the other way. It really just depends on you. They took about the same amount of steps if you take a look at that. See? Looks like we got 1, 2, 3, and then answer down here. So, not one is better than the other. Okay? Get out. Please. All right. Are we good? Any questions? Or not. Ah! No, it's not even, it's the same thing as a, yeah, so. You guys want to try something different here? Yeah, you guys, here. I'm just gonna play. I didn't plan this one. I'm just gonna mess around. I'm gonna move that one over first. So I'm gonna get, let's see, what's this become? The third, 3 times the 5th root of x plus 1 to the 3rd. That's equal to 24, right? What? Oh, you just didn't let me finish. My bad. All right, I'm dividing by 3. Dividing by 3. That's going to give me the...
8.
Yeah, that's going to give me 8 on this side. But over on the left side, I've got x plus 1 to the 3/5. What's up with that 3?
And you put it again.
Hey, it's Monday. I'm sorry. Forgiveness, please. Please. Spare me. Oh, I thought I did it one more time. But you guys okay with the 3 over 5?
Did you just change the back?
I just did it to, yeah, change it into a rational exponent. I just want to try something real quick, if that's cool with you guys.
Do you have to do it?
No, not at all. We'll check. We'll see right now. I love it. Okay. Now, the reason I did that, remember, whatever you do to one side, you can do to the other, right? That's the kind of the golden rule. And I know that if I take this and I take it not to the 3/5 but the 5/3, what would that become? 3 times 5 is 15, and 5 times 3 is 15. So 15 over 15 makes 1, which means I only get the x plus 1 part. But I would have to do it here as well, 5/3. But what is the 3rd root of 8?
2.
It's 2. And 2 to the 5th power, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. And then if I take one from both sides, whoo, there it is. Just like you said. Okay, so that's just a different way of looking at it. Do you have to do it that way, Jaeger? You have to do it that way? No. No. You can stick with the old radicals if you want. I just thought that was a little bit cleaner. If you know what's going on. Right, Taco? Totally up to you. Good form?
I wish I made black fingers because they stick to your face.
They do. They do. But they're metal. And they have like, they fold inward because they have like spring loaded. And then you press them on your nose and they stay. Yeah, so they do have those.
This is like, I feel like they'd be less movable.
Now, you guys good? If you didn't want to do it that way, and you want to do it the other way with the radicals in there, more power to you. Would you like to see that? I know you would. Let me do that. So let's get rid of this. And we're going to leave at 31 because we know that was right. So, I still want to divide both sides by 3. That's going to leave me with the fifth root of the quantity x plus 1 to the third, and that is equal to 8, correct? So what would be my next step using the radicals? I want to get rid of that fifth root, don't I? So I have to take this to the fifth power. So that makes this cancel. You get x plus 1, and I write a 3. X plus 1 to the third. Now, what is 8 to the fifth? You can do it. What would be the next step here? Take the cube root to get rid of this third power, but I'd have to do it as well over on this side. So then I've got x plus 1 is equal to, is it 32? So this is 32. Take that 1, and you've got 31 again. So again, any way you want to do it is fine. I like the first way. That's why I'm throwing that at you. It's whatever you want. If you, yeah, and some people will, because it makes more sense. Right. Right. And there's nothing wrong with it. As long as it gets done. Right, right. It was the one we took on Tuesday. It was in Excel. You took that? I have that. Jesus, Adam, you guys all right? You got some more of that chocolate? Nice. They do. They do. When you had an allowance that was small, that's what you bought right there. You can afford no Snickers or Hershey's. Get some Abuelitas. I'll put it up sometime today. I have a review for you.
For like everything?
I don't know. I have to look at it.
Probably like over 200.
I don't think. Not 200. Only like 100.
Okay.
But again, it's optional too, so it's up to you if you want to do it or not.
I'm doing that.
What you will be doing together is going to be your, we're going to be doing your study plan for the last couple of days. All right. You guys need to see another one? Yeah, go ahead and try that.
No, it's not. It's next year.
See, can you watch your work, please?
No.
Sure.
No.
No, you're.
Try that. You got 2 minutes. That's good, huh? Chocolate. Chocolate.
After you get rid of the 2 and it becomes a 4.
Yes.
What do we do with the 2 again?
You can multiply that with reciprocal.
Like, what do you mean?
Multiply that by 3 over 2, 3/2. It will leave you with the inside piece of it.
Because 3 times 3 is 9.
No, that's not what it means at all. Let me get Lexi real quick.
Lexi's not here.
Yeah, that's what I meant. Whoa, watch your words. please. Who else is gone? Who? Yeah, that was. Thank you.
Ali sounds amazing. Oh my god.
I really was.
Organ or Mr. Ernie, help! Mr. Munoz. Mr. Munoz, I asked Mr. Help.
Oh, you got to score. Oh.
Sorry, I was listening. All right, let's do this.
Oh, okay.
I only have a small amount of time. I gotta go through 5 different topics. So like you said, the first thing you want to do is divide by 2. You're gonna get x plus 3 to the 2/3 is equal to 4. Okay. Now, fastest way, multiply by the reciprocal of the exponent. So multiply this by 3/2. Because that will make this 1, which means you have x plus 3. The square root of 4 is 2, right? So 2 to the 3rd will leave you with 8. And when you subtract 3 to both sides, x has a value of 5. Ben? Thank you.
How did you get 2/3?
2/3?
Or not 2/3, 2 to the 2 cubed.
2 cubed. Oh, yeah, what's the square root of 4?
2.
2. So I'm left with the 3, right? So 2 to the 3rd. Yeah. Because that's what it's saying. This is, remember, it's power over root, right? Power, root. So I can take the root of 4, which is 2, and I'm left with the power there. Good. Debbie, close your laptop, please. It's not open. Alright. We good here?
Yeah.
Yeah, thank you. Extraneous solutions. What does that even mean?
It's extra.
Yeah, a little extra. Sometimes you're going to get a solution that it doesn't work. All that's saying really is when you get to the end, check it. Because maybe it doesn't work. So here's a good example. Let me walk you through that. I want to get that radical by itself. So I'm going to have radical x plus 7 is equal to x plus 5. Cool. Step 1. It's just a addition property of equality here. It's just an addition property of equality. I added 5 to both sides. Okay, addition property of equality. I'm going to use my square property to square both sides. Now notice how I'm squaring both sides. I did it to the entire left side, which means I have to do it to the entire right side. I've seen a lot of people mess this part up and they want to do it to each piece. They want to call that x squared plus 25. Can't do that. It's the whole thing. Okay? Which means now you've grouped it. It's kind of nice on this side because that's just x plus 7. But over here, I'm going to have to FOIL this out. This is x plus 5 times x plus 5. That means x squared plus 10x plus 25. So if you did it to each piece individually, you've lost that middle part. And now you just lost points. Questions on the right side. Good. What's my next logical step? Yeah, bring everything over to one side. So I'm going to subtract x and 7. So I'm left with 0. So I've got x squared plus 9x. What is that? Is it 18?
Yeah,
It didn't look like 18. Multiplies to 18, adds up to 9. Three and 6. 3 and 6. And they're both positive. Okay, so that means that this is going to mean that x is going to equal -3, and x is going to equal -6. So I've got two solutions there. Jaeger, you good?
See, I just be getting lost.
Yeah, a little bit.
Where did I lose you? Are you okay with the factoring? Are you okay with this part? Okay. Remember, this is a zero product property. Because of closure, that's just a number, right? And closure says that's just a number. So something times something gives me 0. What can you tell me about either one of those two numbers? If this was a product of 0, that means either this was 0, or this was 0, or they were both 0. So, if x plus 3 equals 0, then what was x? Right. And if x plus 6 was 0, then what was x in that case? So that's not a 0 at all. It should have been -6, right? So I've got two possible solutions. What should I do with them? Plug them back in. Okay? So let's see here. Let's start with the -3. That's going to give me 4. Square root of 4 is? 2. It's 2? So 2 minus 5 should give me -3. Does it? It does. So it works, right? So we say right here, yay! Now let's check the other one. The other one should be -6. So this is -6. This is -6. -6 plus 7 is 1. Square root of 1 is 1. 1 minus 5 is a -4. Does -4 equal -6? Yeah. It used to. Not no more. They wanted the math to work all the time. So no, this one doesn't work. That's an extraneous solution. You throw it out. Cool? Here's the entire page. Dum dum. We know dum dum.
Where's your glasses?
That driving you crazy? I just want to get back to my conversation. Leandra, you got this already?
What? I gave you your glasses. Yeah, I have to. I wrote it down.
Move on. One more example. You guys try. Give you guys 2 minutes. Go ahead.
That don't mean shit. I know Yes, I did. I forgot. It wasn't this good.
Alexa? Alright, give you guys another 2 on that. Yes. Yes. That should be plus. No, move these over first. Because it should equal 0 1 backwards.
That shit coming from a while. They're like, God, I'm pretty sure Chris has some gay shit. I'm trying to make sure you're fair.
I already have some.
Yeah. Oh, I'll tell you.
What's negative then? Where'd the negative one come from?
From the...
Oh! It's so much!
Alright, let's do this. Let's move over the 3. That's a subtraction property of equality. You're left with this. This point, square both sides. That's gone. 5x minus 1 is equal to x squared minus 6x plus 9. If you don't know where that came from, you need to come see me for tutoring. That was a couple months ago. Let's move everything over so we get equal to 0. Minus 5x plus 1. That's still subtraction property of equality. Ugh. So 0 is equal to x squared minus 11x plus 10. And now I can factor that. So when you do factor it, 2 numbers that multiply to 10. Now, yeah, these are either 2 positives or 2 negatives. What are they going to be? 2 negatives, because they got to add up to that. And they're simply 1 and 10, which means x can be 1 or x can be positive 10. Let's check them. If we put 1 in here, 1 here, 1 here. 5 times 1 is 5. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 gives me 5. Does 5 equal 1? No. Let's put a 10 in there. So 10, 10. 5 times 10 is 50. 50 minus 1 is 49. Square root of 49 is 7. So 7 plus 3 is 10. Does 10 equal 10?
Yes.
Yes, it does. So that one is, it's good. It's good. Alexa, be quiet.
I went to this like when I was in Vegas. There's like this magic shop food in there, and it was guys like, "What's your name?" Like, trying to party like, "No, so Alexa." Like, conversations.
Nice. I remembered you because we got the Fire Stick came in, the new one, and it's got a little button for Alexa, and I was like, this is kind of cool. It's kind of like super lazy.
I know.
The fire stick worth getting.
I think
Yes,
so.
I like it. I like it because I have a Chrome, but the Chrome only works through your phone. So you have to go through the unlocking and waiting to reconnect, while the Fire Stick has its own remote,
But
which
it,
makes it much easier.
So they work. It works with Alexa, right? Fire stick.
Yeah, it has Alexa built into it.
Oh, 'cause I already have Alexa. So I was gonna get my grandpa the fire stick.
Yeah, get the Fire Stick. It's way better. Oh, I don't want to say way better, but
The Alexa's weird. Like even when you're home alone, like she'll just start playing music. You don't talk to her. It scared the shit out of me.
all right. You guys have been good. You guys have been good. I know, but you always know that there's that one problem at the end that is just the kicker. This is the kicker. So, I only have what? Is that a challenge?
Yeah, challenge.
So, again, watch me do this one. I know you're going to be tempted to take notes. I'll let you do it. Again, it's also on the recording. But we kind of already did something like it. I do have two radicals in there. I don't want them to be on the same side. That's just not going to help. So I'm going to move one over. This problem is going to become the square root of 2x plus 1 is equal to 1 plus the square root of x. Questions on that step? Anybody? All right. Here we go. I'm going to square both sides. That's going to give me 2x plus 1 on the left side. Now on the right side, from foiling, I'm just going to get 1 plus 2 square root of x plus x. That just came from the foiling part. I'm going to move whatever doesn't have a radical to the left side. So I'm going to subtract 1, and I'm going to subtract x. So this is gone, this is gone. I've got 2x, that's gone, and I've got x on this side. That should be 2 radical x, my bad. 2 radical x. Are we good? I'm going to divide by 2. Good. Divide by 2, divide by 2, this is gone. So I've got x over 2 is equal to the square root of x. How do I get rid of a radical? Square it. So I'm going to square here, and I'm going to square here. That gives me x squared over 4 is equal to x. Okay? I'm going to bring x over now. So x squared over 4 minus x is equal to 0. What do they both have in common? X. I'm going to factor out an x. Do I want to factor out maybe a quarter x? Well, what is dividing by 4? What's in front of x? It's a 1, right? So I'm bringing, this is 1 quarter. Do you see it? So I just took that out with x because that would leave me with x minus 1 is equal to 0. Which means x is equal to 0 or x is equal to 1. 0 from this part and 1 from that part. If the last part's the one that's getting you, then come see me for some tutoring. Because the last part shouldn't be the hard part. It should have been everything before here.
Everything down, I don't get.
What?
I don't get everything down.
I'll do it again. I'll do that part again, okay? Let me get rid of this.
You lost us. Yeah, you like speak quick. It was like,
What? All right, let's go back to the beginning. I got 5 on it.
I got 5 on it too.
We all have 5. Okay. Are you good here? I just moved over the square root of x, right? And square both sides. Because of that, this is gone. So I've got 2x plus 1. Are you okay with the FOIL part?
yeah.
Okay, so that gives me 1 plus 2 square root of x plus x. Now I want to get rid of all square roots. I don't want them there. That means I've got to move this 1, and I've got to move that x. So minus 1 minus x. That makes this go away, this go away, this go away, and I'm left with 1x by itself, and that is equal to 2 square root of x. Right? We're good now? Okay. I want the square root by itself. I'm just going to divide by 2 here. So that leaves me with x over 2 equals square root of x. To undo that square root, I'm going to square. So that leaves me with x squared over 4 is equal to x. Now, I'm going to change the way this looks so you can see a little bit better. That is 1/4 x squared minus x gives me 0. Because I just moved that x over, okay? So this, moved it that way. We good? Okay. Now, I want to get rid of that 1/4. I'm going to factor it out. Oh, wait a minute. I don't think this was even right. I apologize. I'm glad we did it again because those answers I gave weren't right. I know, they looked too easy, didn't they? They look too easy. If I do factor out that 1/4 x, I am left with x inside here. But the second part, remember, I've got to get back to a 1, don't I? So 1/4 times something should give me 1, and that's going to be a 4. Right? So that means this part will give me x equals 0, and the other binomial will give me x is equal to 4. Yeah, well, yeah, but I forgot to, because I have to fold this out to get back to here. So the way to I get my 1 back is by having a 4 here, because 1/4 times that 4 will give me 1 back. Okay? Guys, it's recorded. Go back, take a look. I'm going to stop this now.